Welcome to Spring LIB.
We're told that we have two first-order spectrum of lines are measured with a spectroscope, which has N, the number of lines, equal to 9,650 lines per centimeter, which is equal to 9.65 times 10 to the fifth lines per meter. And it says that they're measured on either side of center, and it gives you the four values for either side of center, and it wants us to calculate the wavelengths based on this data. Well, first things first, the distance between the gratings, d, is going to be equal to 1 over n. And the equation that governs the diffraction angle for these gratings is d times the sine of the angle of incidence, sine theta, or excuse me, sine of the angle of refraction, sine theta, is equal to m times lambda. Well, in the first case, let's consider when m is equal to 1. Well, when m is equal to 1, we have two values for either side that are measured for the angle theta, or theta 1. So our value is going to be the average of these two. And the two values that we're given is 26.38 degrees, so 26.38, plus 26.18 here. We're finding the average. So this is going to be divided by 2. And we get an angle here equal to 26.28. Okay, so you say at 26 degrees and 28 arc seconds, or arc minutes here. So we have, then when m is equal to 1, we have d sine theta. But again, let's just go ahead and we said d was equal to 1 over n. So we have 1 over n times the sine of the angle theta 1 is equal to m lambda, but m here is equal to 1, so we'll just call this is equal to lambda sub 1. We can rearrange, and we find that lambda sub 1 is equal to sine theta 1 over n, right? So we just kind of flip that equation around to make it put it in the notation that most people are used to, where the thing you're solving for is on the left. Plugging in the values that we know into this expression, we find that this is equal to 4.62 times 10 to the minus 7 meters. Wavelength is commonly written in nanometers, so you could convert it to nanometers if you wanted to, but I'm just going to leave it in meters. So it's 4.62 times 10 to the minus 7 meters. Now we're just going to do the exact same thing, except for when m is equal to 2. So this is the m equals 2 case. Let me underline the m equals 1 case there as well. Okay. So when m equals 2, let's find theta 2. Again, we're going to do the exact same thing. I'm just going to average out the two values. So it was 41 degrees and 2 arc minutes plus 40 degrees and 27 arc minutes, all divided by 2 to get their average. Okay, so this ends up being 40.45. Arc minutes. Okay, where again, of course, it's out of 60, right? So now that we know that, we can solve for lambda 2. So we have lambda 2 is equal to sine of theta 2 divided by m times n, where m is 2 times n. Plugging those values into this expression, we find that this is equal to 6.76 times 10 to the minus 7 meters. Again, I'm going to leave it in meters instead of converting it to nanometers, but either one is correct. Let's go ahead and box that in as our solution to the final part of the question.